What makes boiling water in an open pot an isobaric process? Imagine boiling water on your stove and wondering what makes this simple act a special kind of process in thermodynamics. Well, it turns out that boiling water in an open pot is a perfect example of an isobaric process. In science, an isobaric process means that the pressure stays the same during the entire process. When you boil water in an open pot, the pressure on the water is always equal to the atmospheric pressure outside. Since the pot is open, the air around it keeps the pressure constant, no matter how much heat you add. As you turn up the heat, the water temperature rises until it hits its boiling point at that pressure. At this point, the water starts turning into steam, which is a phase change from liquid to vapor. During this change, the temperature of the water stays steady because all the heat energy goes into changing the water's state, not increasing its temperature. As the water turns into steam, it takes up much more space, causing the volume to expand. This expansion pushes against the air outside, which is part of the work done by the system. Because the pressure remains fixed at atmospheric pressure, this process fits the definition of an isobaric process perfectly. It's important to remember that boiling at different altitudes happens at different temperatures because atmospheric pressure changes. At higher altitudes, the pressure is lower, so water boils at a lower temperature. This is why cooking times and temperatures vary depending on where you are. Understanding how boiling water in an open pot relates to an isobaric process helps us see how energy, pressure, and phase changes work together in everyday life. It also explains why heat is used during boiling without raising the temperature during the phase change itself. So, next time you see water boiling, think of it as a simple example of a process where pressure stays constant while other properties like temperature and volume change.